let's talk a little bit about naming your variables. Um, First thing you need to know is that each variable must be unique within its scope. If it has method scope, the variable will be deleted once the method finishes running, so the name must be unique within that method only. The second thing is that they are case sensitive. The foo variable and the foo variable with capital letters, they are not the same variable. So, well, this is not confusing for the computer, but it is confusing for you. So you should not name variables this way. Later on we'll get to an exception to that rule, however. A good way to do it is to have a verb in the name for a method, because methods do things, they execute code. And you have nouns or adjectives for variables because they store information about what a class is like, or possibly you use a noun to label the actual data instead. There are two different casings that you can use. You can use camel casing. It is not the same kind of casing as in Wikipedia or another wikis, where every word is written together with each letter, each initial letter being a capital one. It looks very much the same, but the first word does not have a capital letter. All the other ones do. So this one does not, but all of these have a capital letter. Then it is called camel casing, and you use this for parameters and fields, and that's about it. There is a second casing called Pascal casing. This one looks very similar, but it is more beautiful because it has the initial letter capitalized too. And this is used for everything else. The reason why there are two like this is because parameters and fields, they are only used within your method or within your class. So they are just for you, so they don't need to be that pretty. And other things that other programmers might see, they should be beautifully written so that they know that it is for them and not some internal shit that happened to be publicized. A less important rule is that if you have an acronym, only capitalize the first letter of the acronym, so that the ML in XML, for example, are not. It looks more like Pascal or camel casing if you do it this way, so it looks more unified. There are some non-alphanumeric characters that you can use, but you should probably not do it, and should probably avoid abbreviations as well. A name such as XML file is much more clear than if there are numbers and other weird characters in there. Now there is a third notation method, except for camel casing and Pascal casing. There is Hungarian notation, and with this one you include meta data about the variable in the name. The B that I underlined, for example, means that this is a Boolean, and this is good. This was good a long time ago in, for example, C or C++, when the IDE might not have provided that information. But in Visual Studio and Visual C#, we get to know that it is a Boolean just by hovering the mouse over the word. So we don't need to include that in the name. Okay, I just want to mention that there are two different kinds of memories. This is not important, it's just so that you will learn these two words early. You will hear them later on, perhaps. So if these two memory types don't stick right now, then that's okay. The first type is the stack. It is an area in memory that is very fast. Usually the variables put in the stack, they have a very small scope, such as a method scope, for example. Because each slot is very small, that's what makes it very fast. Usually it's just 32 bits, and every slot is the same size. So the stack is very fast. But then there is another area in memory that is called the heap. Um, and this one is relatively slow. I wouldn't say that it is slow because memory is fast by nature, but compared to the stack, it's slower. This is where you put large chunks of data. For example, if you pack up a class, for example, then you would put it on the heap instead, because that one is definitely not 32 bits long. So big things, they go on the heap. I'll get to value types and reference types next, so I can show you which things more clearly go on the stack and the heap, which will make you understand why there are two kinds of memories. Another concept that you need to know about, they are value types. This is a data type. Remember, first you declared a data type and then a label when you try to make a variable. And all the ones of these kinds of data types are called value types because they store everything on the stack. They are very small. I can show you an example. Boolean, for example, can only be true or false, so it's actually just 1 bit. So it fits very easily on the stack, which can store up to 32 bits. Well, that's not fully true. It can store a bit more than 32 bits, but it's a good rule of thumb to think of 32-bit chunks, because Windows is a 32-bit operating system. Anyway, when you assign one variable to another, then you get the first one from the stack, which means that when you're gonna put the value into the other variable, it's taken from the stack and copied and put on the stack again. So you have the same variable, same kind of data in two different variables in two slots on the stack. When we get to reference types, you'll see that they are not the same. But for now, just take that at its face value. There are two kinds. There's unsigned and there's signed. The unsigned ones cannot have a decimal, cannot have negative numbers, so they are only positive numbers. Boolean, for example, cannot be -1, it can only be 0 or 1, so it's true or false. The most common one to use among the unsigned ones is the Boolean. The other ones you will not use that much. You can possibly use the unsigned integer, but probably not. It is much more common to use the signed integers because they can have negative numbers, so they're a bit more flexible. And the most common one is probably the integer, because it stores whole numbers in 32-bit chunks, so they are pretty fast for a Windows operating system. And the second one that you will use a lot is a float, because it can store decimal points as well. The float is not 100% precise. The last digit here, or digits, could change sometimes a bit unexpectedly. It has to do with the hardware architecture of a CPU. Usually that is not a problem though, because if you use a float to store the location of a box in 3D space, it doesn't much matter if this number is changed, because it doesn't move an entire pixel, which would mean that this number would be changed. So don't worry so much about that, but you should probably not use floats for bookkeeping or something like that. The second type of data is the reference type. They are slightly different because they store the data on the heap. And remember, the heap was the place where you could store big things. And to be able to access that data on the heap, it stores a reference. That's why it's called a reference type, or a page number. If you consider the memory slot being a page in a book, then it stores the page number on the stack. So it goes pretty fast to access that page number. And when you need to access the data, of course, you still need to resolve that reference from the page number to go and find it on the heap. But when you assign one variable to another, then it doesn't copy the actual data which is on the heap. It just takes the page number on the stack, makes a copy of that page number, and then you have two references that point to the same memory slot on the heap. So you never get two copies of the object, for example, when you pack up a class. The two most common ones to use, they are the string, which is text basically, and an object, which means you pack up code, you pack up a class and put it in memory. One side effect of having value types and reference types, I'll show you, value types and reference types, is that value types, since they you get a copy of the value, that means that if you change that copy, the original value is still the same. That's something to think about, because with a reference type, it doesn't copy the object, which means that if you change something in an object, it doesn't matter which reference you're using to access that object, it will change the only copy of it anyway. As with all things so far, the theory is not always clear, so I'll try to do a bit of practice. And as before, if you don't get everything when I do this, then don't worry, because we'll do it again and again many times over, so sooner or later you'll get it. But if you have heard the vocabulary first, it will be easier to follow along later on. Even if you don't get every detail yet, it's worth it. Okay, let's get over to the code.